Okay, so it is going to be a short week. In fact, after today, I'm only going to see you tomorrow because on Thursday, after all the testing, remember you're going to go to periods 5 through 8 in the afternoon, and then we've got a long weekend, 4 days. You're not back until next week, Tuesday the 22nd. But the plan is we're going to finish up graphing the log parents today. That's not going to take us very long. Tomorrow, we'll go ahead and start the next lesson, and then we'll just carry that on into next week when I see you. Okay. Any questions about what's coming up? We are not having a quiz tomorrow. Okay. I mean, we can have one if you really want to. Another good grade before the Easter break. Okay.
Asian kids will always.
Okay. Okay. Let's look at. Hey, look, math. Whoa. Hey, look, math. It's super cool. All right. Okay, so we've been looking how to graph the logarithmic parent. Now remember, if your base is greater than 1, it's going to be logarithmic growth, seen right here. And if your base is between 0 and 1, well, then you're going to have logarithmic decay, seen right here. Now, every log parent is going to go ahead and cross the x-axis at 1, 0. Once you start to transform it, then that's no longer a guarantee. It can be shifted, can be dilated, or reflected, anything like that. Now, the way that we're doing this is we're actually graphing the inverse parent first, the exponential, then we're taking those x's and y's, and we're just switching them. Okay, it doesn't matter if it's a growth or a decay, and we are currently on this one right here. So this is where we finished up yesterday. Okay, so all we need to do is go ahead and answer the questions about this because we already got the tables, we got the graph, unless anybody needs to ask me anything about those. Do we have any questions? Okay, so looking at this logarithmic growth that we have in red, what's the domain? How wide is this thing? X greater than 1. Remember, we had a horizontal shift, so that asymptote is not on the y-axis, it's actually at x equals 1. There we go. Okay. All the log functions, whether growth or decay, they're going to be infinitely tall. So I'm going to go ahead and say all reals. Okay. Now remember the end behavior, this is considered far left. So the left in this case would be your asymptote, and then we have the far right. Okay. So let's go ahead and match these up right here. So it says as x approaches blank, f of x is approaching infinity. Well, to approach infinity, the y values are going to have to get larger. So it's only approaching infinity on the right side. So what is x going to have to approach to make this happen? Infinity. The further we go right, the larger x becomes, the larger the corresponding y values. It's going to continue to grow. Okay, now let's go ahead and use another color here. So as x approaches blank, the y values f of x is going to approach negative infinity. Well, the only part of this log that's actually approaching negative infinity is right here by the asymptote. So what is x going to have to approach? Okay, oh, 0 or 1? Okay, 1. Now, typically it's been 0 because we haven't had a horizontal shift. But remember, the asymptote is now at x equals 1. So as we approach 1, the y values get smaller and smaller. Okay, good. And then, of course, didn't put the whole point there. I probably should. I think I put that in the wrong spot. That's okay. So the asymptote is x equals 1, and we got our y-intercept from the table here, so that would be 2, 0. Okay. How we doing? Yes. Oh, yeah, it looks like I had that in the wrong blank. That's my bad. Okay, let's look at number 4. Okay, so f of x equals log base 3 of x minus 2. Now, that minus 2, is this a horizontal or a vertical shift? How do we know it's vertical? There's no parentheses. If this was meant to be a horizontal shift, it would have specifically been written like this. It would have been contained in parentheses with that x. Without the parentheses, yeah, this has to be a vertical shift. It's just going to pull it down. Okay. Now, remember, the only transformation that can affect the asymptote is a horizontal shift, because this one's vertical, nothing's going to happen to it. So that means the asymptote, this time it's going to be right here on the y-axis, where it always starts. Okay, so I already know my asymptote is x equals 0. Okay, cool. All right, well, what's my base here? Base is 3, so this is going to be a growth, right? So I can expect this to go ahead and kind of curve up to the right. Okay, so we're going to go ahead and start to graph this by first creating a table for the parent inverse, the exponential. Okay, because these points, these values are going to be a lot easier to get with the exponential, and then we're going to switch. So we always start with the same x's, -2, -1, 0, 1, and 2. Okay. So is everybody okay why I've got 3 to the x? Okay. Well, let's go ahead and plug these in. What's 3 squared? 9. 3 to the first? 3. 3 to the 0? 1. Now, what happens again? I always forget. If I go ahead and plug in a negative number for a power. There you go. You take the reciprocal to make it positive. So this is going to go ahead and flip it. This is now 1 over 3 to the positive 1. So that's a 1/3. Okay. And then what if I had 3 to the -2 power? 1 over 9. Here we go. Exactly. Okay, so now I've got the exponential, but remember, we want to graph the log. There we go. Not the opposites. Just going to flip them. So for this middle one right here, I'm simply graphing log base 3 of x. So all we're doing is going to take the values in that first table, and we're just switching them. So these x's here, they're now the y's. So -2, -1, 0, 1, 2. And then the y values, they're now the x's. 1/9, 1/3, 1, 3, and then 9. Here's the thing, though. We don't want log base 3 of x. We want log base 3 of x and then -2. Okay, so now I'm going to go ahead for a third table. This is where I'm going to apply any transformations that I happen to see. So I want log base 3 of x and then -2. Well, here's the thing. You told me at the beginning that this is a vertical transformation, right? So what values will I subtract 2 from? The x's or the y's? Which ones are vertical? The y's. The y's are vertical, so it's only those that I'm going to subtract 2 from. Nothing is happening horizontally, so those x values stay the same. This is going to be 1/9. This would be 1/3, 1, 3, and a 9. Okay. And now let's go ahead and subtract 2 from each of those y values, because that's the transformation I see. Is everybody okay? So what's a -2 minus 2? Woo! -4. So -2 minus 2 is -4. What about a -1 minus 2? -3. 0 minus 2? 1 minus 2? Okay. Or as we say in math, negative fun. Okay. And 2 minus 2 will give me 0. Okay. This is the table that's going to give me my graph. Okay. All right. Now, you may even get to the point where you don't need multiple tables like this. Maybe once you go ahead and get the exponential, as you switch the x's and the y's, maybe you'll be comfortable enough to go ahead and apply those transformations. Completely up to you. If you want to go ahead and take it so you can organize, that's fine. Let's go ahead and plot these. Let's see. So 1/9, that's going to be just barely past the asymptote, -1, 2, 3, -4 right there. Then we have 1/3, -3. Then we have 1, -2. Then we have 3, -1. And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're going to have something like this. And we knew before it was a growth base, so it has to curve up to the right. Okay, so there's my graph. Everybody's okay? And now we just answer my questions. What's my domain? Okay, x is greater than 0. Now remember, that could be written a lot of different ways. As an interval notation, you can go ahead and say 0 to infinity. Okay. They can also go ahead and write it as a solution set. They can, remember, use the squiggly brackets, all values of x such that x is greater than 0. Remember, I just want you to be familiar with all those different forms, because coming up in middle of May, we have that post test. Okay. So we just want to remember all those different ways. Okay. What about the range again? All reals. It's always infinitely tall. Okay. So let's take a look at this one right here. So as x approaches blank, f of x is going to approach infinity. Okay. Well, am I approaching infinity on this graph on the left or the right side? Okay. It's on the right side. So what does x have to approach to make that happen? X has to approach infinity. The larger x gets, the larger the y values get. Okay. Now, as x approaches blank, f of x approaches negative infinity. Well, the other part of this is the negative infinity. So what's x going to approach here? Oh, wait a minute. The last one approached 1. There was a transformation. That's where the asymptote was. The asymptote is at 0. So that's how it's going to approach negative infinity. Okay. And we see the x-intercept from the table. It is just 9, 0. Okay. How are we doing? Okay. What's that? Not yet. We're going to do one more. We're going to do one more, because you'll notice on number 5, first off, are there any questions on number 4? Everybody's good? Yeah. Okay. So let me go ahead and erase this real quick so we can actually see what we're doing. Okay, so for number 5, we are wanting to graph log base 1/2 of x plus 9 and then plus 4. Okay, so we're wanting to shift it 4 units up. There's a vertical shift. I always forget. Is this a 9 to the left or 9 to the right? Why? It says plus. We take the opposite. Remember, when we add or subtract to x, we take the opposite. Now, look at my base. Is this a growth or a decay? Okay, it's a decay. That base, that 1/2, it's between 0 and 1, so I should expect a graph that's going to curve down to the right, something like that. Okay. Now, I'm going to go ahead and get you started with the table, and then I'm going to want you to finish it. Let's see if we can do that. So for this first table, remember, we're not starting with the log yet. We're going to start with the exponential inverse. So here's x, here's 1/2 to the x. Remember, in the first table, we only are working with the base parent. Everybody okay? And we're always going to start with the same values, from -2 all the way down to 2. So let's start with the easy ones. What would be a 1/2 squared? 1/4. Because 1 squared over 2 squared. Okay. Does anybody want me to write this over to the side? Okay. What about 1/2 to the first? That's 1/2. What about 1/2 to the 0? That would be 1. Now I want to take 1/2 and I want to raise it to the -1. That is going to be 2, yes. And then if I raise 1/2 to the -2, that is 4. Does anybody want me to show the algebra? Anybody not sure about that? Okay. So I've got the first table done. Everybody good to go? Okay. Now remember, for the second table, this is when I'm going to go ahead and change it to a log, but I'm not ready for those transformations yet. So in the middle table right here, I got x, and I'm going to go ahead and graph log base 1/2 of x. So all I got to do is flip the table that I've already created. Okay. So these x's here, they're now y's, -2, -1, 0, 1, and a 2. These y values, they're now the x's. 4, 2, 1, 1/2, and 1/4. All my x's live in Texas. That's actually true, too. It is. Well, technically there's one in New Mexico. That's not. Anyways, so here's what I want you to do. Okay. Now for the third one, this is where we're going to bring in the transformations. Okay. So think about what I would do with the 9 and 4. Is the 9 going to apply to the x's or the y's? Why the x's? Because the 9 is joined directly with the x. Okay, it's the horizontal. So that means the 4 is going to be what? That's going to be with the y's. Now remember, it's only the x's that we take the opposite. With the y values, it's exactly what you think. So the y values, you're just going to go ahead and add 4. But remember, for the x's, you always take the opposite. Oh, let's see. Go ahead and find me those values. So I'll give you a little bit of time to take a look at that. And then I'll go ahead and reveal it, and we'll go from there. Now, at the very least, you told me we're going to go ahead and shift this 9 left, so I'm going to go ahead and start getting my graph ready. That means the asymptote, if it started at 0, where is it now? It should be at -9. So negative 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So my vertical asymptote should be at -9. And then once we're done with this problem, that's all she wrote. Okay, you got the assignment. That is due on Tuesday after we get back, and then we have a quiz over this material next Wednesday. Okay, so there's plenty of time to go ahead and take a look at this. Plenty of time. It's going to be real weird. Yeah, in my AP pre-cal classes, what I did today is what I'm going to be doing with them on Thursday afternoon. That is the history, the STAR history. But then you have you've got some AP mock exams, and I think there's still a few people testing TSI. The 24th is the Algebra 1 STAR. That's a Thursday. So next week, the Tuesday we come back, is a normal school day. Okay. All right, so is everybody ready? Now here's the thing. Remember, for the x's, you take the opposite. So in the formula, or the function, I should say, it says x plus 9. So that means for these x's, you would have to subtract 9. So here's the table you should be getting. Let's see, look at how I got these values. 4 minus 9, -5. 2 minus 9, -7. 1 minus 9 is -8, all the way down. But how did I get the y values? -2 plus 4, there's your 2. -1 plus 4, there's your 3. How many people got the table? Okay. So that's something we'll practice. We'll keep working on that. Okay. All right. Does anybody have any questions? Okay. Well, let's go ahead and plot these points. Let's see here. So my first one is a -5, +2. So -1, 2, 3, 4, 5, +2. Then we have a -7, 3. Then we have a -8, 4. Then we have a -8.5, 5. And then we have a -8.75, 6. So you can see I have exactly enough points to go ahead and get my curve. And remember, it's just a sketch. It's just a sketch. All right. So let's go ahead and start plugging in, or start answering the questions. Okay, what's my domain? X greater than -9. Okay. What's my range? All reals. Okay. Here's my end behavior. Okay. So let's take a look. As x approaches blank, f of x approaches infinity. So what should x approach? Okay, 0. Ooh. Infinity. So at some point it's going to cross the x-axis, but it's going to continue to go down. So as x is getting larger, the graph is dropping. Yeah, so we don't have a horizontal this time. We have a vertical. Yep. Okay. Now let's do the other one. As x approaches blank, f of x approaches negative infinity. Well, I've already used the right side, so we got to be talking about this one. That one is negative 9. There you go. When you're talking about a log, okay, one side of it will always be positive or negative infinity. The other side is always going to be approaching that asymptote. Okay. All right. Now, the only thing we don't have is the x-intercept. And if you take a look, what do I do? You could go ahead and put it in the calculator, yeah. Okay. It is 7-0. Okay, so let's go ahead and plug this in. So log base 1/2. And I think it's good, to finish up with the calculator because you will have those. So I'm going to hit control. How do I bring up a log? Okay, 10 to the x. Okay, right next to 1. Okay. Now this base right here, it was 1/2. I'm just going to type in 0.5. Same thing. And then what we have, it was x plus 9 and then plus 4 on the outside. Okay, so everybody's okay with that? So let's see how we did. Okay. So I'd say our sketch looks pretty decent. Okay. I didn't exactly cross the x-axis, but that's okay. Now, what we're looking for is that point of intersection. You could go ahead and hit Control T, yes. You could absolutely do that. Let's do it this way. So menu, we want to analyze the graph. I'm looking for it 0. Okay. Now, if this is what I want, remember lower bound is left, upper bound is right. So see, it is at 7-0. Okay. Or if I were to go ahead and hit Control T, if it crosses at a nice location, there's my intercept right there. Okay. So there's a lot of different ways you can do this. Now, I will go ahead and throw this out there. I did say this was going to be our last problem. Do we want to go ahead and at least look at the tables for number 6? Do we want to practice that? You want to save this last one for tomorrow? Okay, then we are done.